Hi, this is Zheng Chen from Math Department, UMassD. In this video, I'm going to demonstrate the GUI, the integration GUI in MATLAB, which is designed for the UMassD Accomplished course module for integration. So the students and the advisor will be provided with this whole package, and the lecture integration, this website is the presentation of this module with requirements, with all the necessary knowledge the student need to learn, and also the goal, the outcome. And it is explained in another video, which is the demonstration. And this is the raw file which is used to generate this website. And you're going to be provided with two folders. One is called Integration GUI Student. The other one is called Integration GUI. And in this version, the GUI product is complete. So that is for the use of advisor only. It is not provided for the students. So there are two files. The student will mainly work on the M files. And here I'm going to open this one. The one open here is actually this file. And I will demonstrate how the GUI will look like by running this file. So you need to open the MATLAB recent version. As long as it works with GUI, then that's okay. So you can open this file here and run, or you can just type in the name of this file and hit enter. So here I'm going to run this file. Yeah, my computer is slow. Okay, so now we have this one show up. It still needs some time. Yeah, so this is how the GUI looks like. So you're going to have three parts. One is the plot parts, and one is the input part, so the user can put in the expression of a function, and also the range of this integration. So this is lower limit, this is upper limit, and the user have freedom to choose from different numerical integration methods. So here we cover monte-Carlo methods, middle point rule, trapezoidal rule, Simpson's rule, Simpson's 3/8 rule, composite middle point rule, and composite trapezoidal rule. So for the last two, if you choose them, you need to provide the number of sub-intervals you're going to use. So let's take the middle point rule, for example. So this is the full product. So once I hit calculate, it will tell me the results. And also we'll have some demonstration here for the area that is used to approximate integration, the area under the curve. But in the student's version, it cannot be run. It will tell you errors because the key parts for calculating is missing, and the student need to fill in those parts for the GUI to run properly. So let me demonstrate how it looks like here. Suppose we're doing with cosine x squared function, and we're integrating from 0 to 2, and we're using middle point rule. And once you finish selecting all those options, you click calculate, and the results will show up here. So you will see by using middle point rule, the integration from cosine x squared from 0 to 2 will be approximated by 1.0806. So that's the results. And the demonstration here tells you what is the area, what is the region that you are using the area of this region to approximate the integration, right? So by the way, the blue line here, the blue curve here is the plot of the integrand function. So if you want to change that into another one, say 2 plus maybe 0.5 plus 2 times assign x cubed, right? From 0 to 1, 0 to 3. Let me just leave that. So if you change this and then you hit calculate, you can see this is the plus of the integrand, and the red one is the area we're using to approximate this integration from 0 to 2. And it's using middle point rule, so it's actually using this middle point to form this rectangle and use the area to approximate that. So this is how it looks like. Let me show you other methods. The trapezoid rule is this, right? The form a trapezoid. Simpson's rule, well, for the Simpson's rule, I didn't give the plus of the area. And for Simpson's 3/8, you get the results here. And for the composite middle point rule, so suppose we are using 10 subintervals, they're equally spaced subintervals, you hit calculate, you will get the result approximate by these rectangles, right? And if you use less, say 5 of them, then you will use these areas to approximate it. So same thing for the composite trapezoid rule. So we go with 5, we have this 5 trapezoid. If we increase that to 10, you get this. So basically, this is a finished product. This is what expected for the finished product. And the students need to, oh, sorry, the last one is Monte Carlo methods. And that's just using random points and use the average of those points value to approximate this integration. So that's what is expected. And for the students, they need to fill in the blank parts so that the rest of this will work. In the student version, the Monte Carlo method will work because it's not required for the student to code up, but all the rest are relatively easy and the students are expected to code them up. So that's what expected for the finished products. And let me point out where the student need to work on. So in the student version, it looks like this. And there are many intervals here. The student should look for this function, the function named as calculate push button callback. This is also talked about in the demonstration in this website, so the student know where to look for. And under this function, in this function, some preparation already well coded, so students don't need to worry about this, but students need to understand what those means. So the x1 is the lower limits, x2 is the upper limits while reading from the interface, and fx is the function of the integrand. It's also read from the interface. And these are some preparation. And this will tell you, or this will read from interface so that the code know which method we are looking for. So for different methods, it's going to assign different number, and later the code know where to. For example, if you're using Monte Carlo, then this will be assigned with number 2. And then later on, once we calculate the integration results, it will go through several if clause, and we'll start executing the part that with the same number. So for Monte Carlo, it will stop here, get into this if clause, and finish executing all the sentence here, and then exit out here. Since for Monte Carlo method, it doesn't satisfy all the following if conditions, so we'll skip those, and then end up doing the plotting things. And for this part, it will execute what is the Monte Carlo, what are the points that are being used, and show them in the product, just like I demonstrate those blue points and the red points, right? So this is for the case of Monte Carlo. And the students need to finish all the others. So for the middle point rule, this is the part that students need to replace via the working codes. So at the end, the student need to assign integral equals to some value. And maybe they need several lengths before this, several sentences before this to be able to assign the value here, right? So that's okay. So the student need to assign some value here, and then this sentence basically tell the GUI that the results is the same as integral, and then the GUI will show that in the results place, right? So that's how it works. And same thing for trapezoidal rule, Simpson rule, Simpson 3/8 rule, the composite version of midpoint rule, the composite version of trapezoidal rule. This, for each one, student need to fill in the blank so that the integral is the correct value provided by the approximation formula for each method. So that's what the student need to do. And once the student finish in all these blanks, the product should work as I just demonstrated. And student don't need to work on other places. So that's it for the requirements of the students. And also in the plotting part, I didn't plot everyone. So if the student interested in fill in the blank for the missing ones, it's okay. They can do that. They're welcome to do that, but that's not required. So that's it for this demonstration.